Question. Interference in thin films, it's a part of syllabus and very important also. Just some around 10 or 12 numericals are there. Just work out them, they'll be sufficient. First read the question, you'll get some idea what has to be done. We have to just discuss the interference between R1 and R2, that's all. So what about R1? R1 is reflected by the air film. So no phase change for this. What about R2? R2, what happened? The ray will go there, will pass through the air film, then get deflected by denser medium, again will pass through it. So when you compare the interference between R1 and R2, there will be path difference of 2t because the refractiveness of air is 1. So 2 mu t should be there, the refractiveness of air is 1, 2t due to path difference. And also it will get reflected, no? So therefore for constructive interference, what you can go for? The reverse of that condition for constructive interference between R1 and R2. This should be equal to 2t plus (2n). Okay, then again two wavelengths are there, no? We'll write it as some n1 plus 1 lambda 1 by 2. It was found that only two wavelengths interfere constructively and it lies between 0.4 micrometer to 1 point. The wavelengths ranging from 0.4 micrometer to 1.15 micrometer. 0.4 or this is so the correction is there. I'll make it. Yeah. What about the other wavelength lambda 2 is asking? Okay, I think this everyone will agree. Two n minus 1 lambda by 2. Here 2n 1 plus 1 will take it. And now what about the other wavelength? For other wavelength, again same thing. Now we know lambda 1, we know t will get the n1. We have to work out this. T is how much? Thickness 0.5, 10 to power of minus 6, 2n1 plus 1, lambda 1, 0.4 by 2 into 10 to power of minus 6. Anybody give me value? N1? Okay, that was 0.2, 1. N1 equal to 2 will get it. Now look at this. We have lambda 1 equal this much, 0.4. So what do you expect? Lambda 2 must be greater than lambda 1. If lambda 2 should be greater than lambda 1 means, what do you expect the other n2? What is the next possible value of n2? Shall we take 1.5 or something, or next possible as lambda 2 greater than lambda 1? So the n2 must be equal to 1 because n2 should be less than n1. So what is the possible value of n2? Next value is only 1. 0 cannot be. See the product of these two, this one, it should be like it. So lambda 1 wavelength is lambda 1 we have picked up. The other wavelength lambda 2, definitely range is telling this is the lowest value. The other wavelength should be greater than this. For lambda 2 greater than lambda 1 means what is the value of n2? N2 can take values of integers only 1, 2, 3, 4, 5 like this. Already n1 has taken the value 2. What is next possible value of n2? Either should be 0 or 1. 0 not possible, so I'll pick up 1. Substitute the value of n2 here. Now get the other wavelength. Very nice problem. I just wanted to test your why it has become like this. Actually, condition for constricted inference should be equal to n lambda, no? The path difference should be equal to n lambda, because this ray after undergoing reflection will undergo phase change of pi radian because it's reflected by denser medium. That's why for constricted interference we have to write equation of like this. Two more problems we have.